will be the set of all lines passing through 1 comma 1, and A and B represents set of all point of intersection of tangents at the endpoints of chords belonging to set L to the curves circle and parabola. Then we need to define the set A and B and what does it represents. Now this is quite a standard problem and you can see clearly the solution on the screen. So we'll have infinitely many lines which is passing through 1 comma 1, right? This is set of all lines. If all of these lines behaves like a chord to, let's say, a circle, x square plus y square equals 4. So any of this chord will definitely intersect circle at 2 points, let's say at point A and B. At these 2 points we are drawing tangents and we need to find locus of point of intersection. So let's change the chord now. The tangents drawn to the circle and the point of intersection of chord will meet at point P2. Let's say this point is P1. Let's take one more case where we have some random chord and draw these two circles. They'll meet at P3. And in order to tell where exactly these three points will lie on. Surprisingly, the equation of chord is given by t equal to 0, and in detail I have already given the logic behind this. So in the first case, let's say if the curve is circle x square plus y square equal to 4. So with respect to a circle, if I'll draw t equal to 0, I'll get replace x with xx dash. So xh plus y equals 4, which I've written over here. And now since this chord is passing through 1 comma 1, hence if the point of intersection is h comma k, that must satisfy h plus k equals 4, which shows that the locus of this point from which the tangents drawn meets the circle at point A and B, and the chord always passes through 1 comma 1 will always lie on this line, right? So that is quite interesting to see. We can do exactly same thing for parabola. So again, with respect to parabola, I will write t equal to 0, and the equation that will get is y dash ky minus 2 times x plus h. So what am I replacing? Y square with y dash and x square with x dash, x with x plus x dash by 2. These are the usual things which you must have done. And t equal to 0 gives this expression k minus 2 which equals 2. So that's also represents a line. In fact, this is very crucial idea where if we'll take any conic in general, and let's say there are chords passing through the fixed point a comma b, and if you are going to draw the tangents drawn at the end of that, so the locus of the point of intersection of tangent is always going to be line, because the equation of, let's say, the point of intersection, because let's say the point of intersection is alpha beta. So with respect to that point, if I'll draw the equation of chord of contact as t equal to 0, and the equation of chord of contact will be of linear nature, which will be satisfied with the fixed point a comma b, and hence alpha comma beta will be forced to lie on the line. So I can tell a and b represents line, and number of intersection of a and b, because now just you can solve these two lines, and these two lines are not parallel, so they'll intersect exactly at one point. So the answer for this problem is A and C. I hope you are enjoying these lectures as well as it's quite educative for you. So please do like and subscribe the channel if you want more quality content.